So, I want to make an online game where you can save and continue playing whenever you want. But I do not like yelling at my computer, so a database on the server is not an option. One solution would be to save the game state as a cookie. This has multiple downsides, like what if I want to play in incognito mode, or if I want to continue playing on another computer. And the biggest problem, cookies are banned in Europe, leaving only one viable option. Store the game state in the most powerful computer known to man, the human mind. Hi, welcome to this devlog series, where I will go through the development process of making a simple roguelike, currently called 6-Word Dungeon. So, I want to make a game where you can save your progress in your mind. This has many limitations. For example, even though the human brain is thus far the most powerful computer we know of, it's surprisingly bad at remembering specific information. So dumping a massive binary on the screen that needs to be exactly replicated to continue is not going to work. We need a way to encapsulate a lot of information in a tiny nugget that is easy to remember. One way to do this, and that has already been used in games like Minecraft or Binding of Isaac, is a world seed. In the case of Minecraft, this seed can be used to generate an infinite world which will always be the same and with some caveats regardless of when or where you use it. So one part of the solution is to use a world seed to store the world state. This only leaves the player state, player health, the weapons or abilities they have, and money, objects, that kind of stuff. The size of this information can be reduced by having a preset of limited weapon types and ability types. Then you just need to store a set of numbers that indicate which specific weapon or ability you have acquired. This results in a game state that looks something like this, which could be reduced to something like this, and then encoded into a base 64 string with some checksums to make it hard to guess a valid code. This is still hard to remember and not easy to write down. What I've come up with is a function that turns a game state into a string of 6 words that can then be decrypted again into a game state. 6 words is probably still a little too much to remember without putting effort into it, but it is at least easier to write down than, for example, base 64 encoding. What this would look like in practice for a player is that every time you clear a level of the dungeon, the server returns a new level and a 6-word code. If, after clearing a level, you want to do something more useful with your time, you can simply write down the 6 words and continue playing another time. So, has this been done before? And, as with many ideas, the answer is yes. Many times, actually. The original Nintendo Entertainment System did not come with writable memory, making digitally saving progress impossible and leaving game developers with no other option than to develop something similar to what I'm doing right now. One example is Mega Man 2, published in 1988. To start the game where you left off, you would actually have to enter a combination of 9 dots in a 5x5 grid. This combination corresponded with how many energy tanks you had acquired and which enemies you had defeated. Some quick calculations show that the code possibility space, so how many different codes could be entered, was about 2 million, and the game state possibility space, how many different game states were possible to save, were 1280. Reverse engineering this was, in the 80s, without easy access to the internet, not a trivial task. But it was also not impossible to notice patterns. Currently, there even is an open source safe code generator on GitHub to start the game in whatever state you would like. If you would like to know more about the quirks of retro game development, I really recommend Kevin Zurawel's talk at the Strange Loop conference. In this talk, he mentioned some other games like Punch-Out, which used a 10-digit code, giving it a code possibility space of 10 million. And after some googling, I found a post explaining this system, which allowed me to calculate the game state possibility space, which is about 260,000. But not only are the possibility spaces bigger, they also used a combination of checksums, bit shifts, and bit shuffles to make reverse engineering it extra hard. All in all, this system was not ideal, so Nintendo eventually released ways to digitally store gameplay on the NES, and with the SNES this technology was forgotten in history. So, with this history in mind, let's go over some challenges I might encounter and how we'll try to solve them. Number 1. Guessing. The idea is, of course, that you store progress of actual gameplay, not that you create a cheat code machine. As you could see in Punch-Out, they put a lot of effort into making it hard to guess valid game states. Only 1 in 40,000 combinations was actually valid. And even if you guess right, the bit shifts and shuffles make it hard to predict which code corresponds to which game state. So I'm not going into a lot of details on how I have approached this, because this will defeat the purpose. But using words makes it really hard to use standard analysis or decryption methods, so I hope that will help. And using big numbers will help as well. Leading us to the next challenge, possibility space. Possibility space is a balancing act. You want to optimize three things: save code length, the shorter the better, the size of the game state you can save, the bigger the better, and the chance of randomly guessing a valid code, the smaller the better. This guessing chance is simply a function of the game state size divided by the save code size. Looking at this table, you can clearly see that Six Word Dungeon has an astronomically bigger game state possibility space than the other two, and about the same guess chance as Punch-Out, which is roughly 1 in 100,000. The reason I can, hopefully, get away with a much bigger code size is that I can use words, which are more intuitive to remember and write down than dots in a grid or raw numbers. One way to make the code even more memorable would be if the words formed a grammatically correct sentence. This would make for an interesting coding challenge, but would also lead to a longer string of words. And for now, I think less words is more better. Challenge 3. Bad words. One problem that words have that dots in a grid or raw numbers don't is that you can write bad words. You could argue that 420 or 69 are bad numbers, and technically you can draw something approaching a swastika with 9 dots in a 5x5 grid, though luckily this would not be a valid code. With words, however, you come across this problem way quicker. For example, while testing my system, I came across this combination, which is, well, problematic. To solve this, I will have to manually curate the list of words I use to encode the game state, and this list is long, and I haven't started yet. Another challenge is that this is a solution to a problem that does not exist. It is just a nice gimmick that I wanted to program, but implementing it will take extra development time, constrain the scope of the game, and might make the game actually less user-friendly, leading to the next challenge. It is nice that I have an algorithm that can turn a game state into 6 words and back again, but as of now, I actually don't have a game yet. And this is where the next videos will be about. Thank you for watching.